We're fortunate that the program's ongoing. We are running a little bit late. Apologies for those people following it virtually. Now we have Marie-Louise, who, please come on stage. I want you to introduce yourself. I want to say where you have gained this experience, this very clear thinking, and what the audience are going to be able to take it away from listening to you.
Yeah.
And then please carry on with it.
Okay, I will. Thank you so much. Yeah. As is written, I'm Marie-Louise Rosholm. I'm a textile designer, and I have my own studio MLR. I've looked very much forward to talking to you today because you are a knowing audience, and I want to thank Performance Days for giving me this possibility. My studio is in Copenhagen. I started it out in Milan. My main interest to textile design has always been materials. For the last 15 years, I've been focusing on sustainable, circular and regenerative materials and processes, always with an industrial approach. So if you want to know more about this, then we can talk about that later. Now I will continue with the theme, or go to the theme of this day. So I'll start with explaining a bit why I am so obsessed with monomaterials, why complicate life, actually. The garments that we produce today, they will be at its end of life in 5 to 10 years. That is, if we agree on making good stuff that can stay around for a long time. Which in any case is the best you can do for people and planet. So this is, of course, what we're going to do. We can have ideas about how textile recovering, mechanical or chemical, will be in this span in 5 or 10 years, but we don't really know because the development is going so fast, luckily. The challenge is enormous. It's just as enormous as the mountain of waste we produce. And I don't have the courage to trust that someone will find a way of cleaning up after what I do in time and in one stroke. Apart from stop consuming, which is anyway not going to be a solution for all people in the world, what can I, as a designer, do to take up this current, what can I do in this current situation? Oh, that was something wrong. I can try to make things as simple so it will be easier for the future to reuse, regenerate, and elaborate them. So these things will not add to the mountain of waste we have. If we continue to focus on how to transform the waste, we will continue to have waste. We have to start from another point of view. We have to start with the start of the product. How can we design an item so it will not end up as waste, but will continue as a pure raw material? Remain on its initial quality level, that's going to be a challenge, and it's probably not going to happen, but as a pure renewable material. So if we don't construct the textile specifically for the first product that we use it for, then we don't conditioning for the rest of its life, or for the lives to come. It's a bit complicated. An example. If we have a material blended into incompatible fibres, then it will continue to be a blended material of these two incompatible fibres, unless we recover it in a resource heavy process where we split the materials. One way of making things simpler is to make it easy to disassemble it, the different parts, and another is to keep the material streams clean So no extra resources are needed to split the different non-compatible materials. That is why I'm so focused on monomaterial. The new EU textile strategy that was announced in March, I think, is addressing the same topic, not as extreme as me, but it is addressed there. So how do I define monomaterial? By monomaterial, I don't mean one material. I mean materials that contain the same substance. So we have cellulosic, which is cotton, linen, hemp, lyocell, and all these plant fiber fibers. And they are compatible, so it's fine to blend them. The same is valid for kind of wools and silks, being animal fibers. I'm not strong in details of synthetic materials, so I won't say anything because I don't want to risk to say something wrong. If you only mix fibers from the same group, then we can preserve the raw material unpolluted for a clean, easier recovery. We can also maintain compatible materials better in washing and ironing. If we blend an animal and a plant fiber in the same fabric on the same garment, then we should ideally wash it with 2 types of soap and iron it into different temperatures. That's not possible. And therefore, the fabric will not remain as strong as beautiful for as long as it could. And it will become ugly quickly. So, but this new pure solution must be without loss of function, without loss of aesthetics, and with the same durability. It's only a very tiny group that wants to dress bad and grisly for the sake of their opinion. The new sustainable, regenerative, and monomaterial fabric has to be at least just as good, if not better, as the conventional textile. So, just a second. Yep. I have 2 examples I want to share with you to illustrate the thinking and the research, the considerations I have done from idea to final product. And there's nothing new in it because it's what we all do when we develop new things. The only thing is this self-invented set of rules, and in this case, that is that all fibers must be cellulosic. This is the first moisture management fabric developed in 100% cellulosic fibers. It started when I discovered kapok, actually here in Performance Days 3 years ago. The kapok tree is a very, very, very big tree. It's growing a non-food fruit. This hard fruit contains kapok fibers, and these fibers are the tiniest. 14 to 15 millimeters long, they're very thin. And they consist of only 56% of cellulose. The rest is air. And because it has so little substance, then it cannot absorb and it cannot hold moisture. And that is why it can keep the body dry. Then it's also covered with a very fine layer of wax that will reject the moisture. So it's a hydrophobic fiber. It's very hydrophobic. Then the tree has positive impacts on its habitat, and it thrives without human invention, and the fiber is regenerative. It's also biodegradable, but I'll get back to that. So, good. As you probably know, most of you, tensile lensing modal is a cellulosic man-made fiber made of wood. The characteristics of the lensing modal black or color is that the color pigment is incorporated in the fiber during the fiber extruding. This saves 50% of water and energy compared to a conventional dyeing. What interested me about this in this case was that we could spin a melange yarn with modal color and kapok avoiding yarn dyeing, and that means that we could preserve this very thin layer of wax. We could also avoid piece dyeing. Sorry. So, my theory was that because kapok is hydrophobic, an amount of this fiber can keep the body dry. And because the modal, being the most hydrophilic lyocell fibers, it will absorb the moisture. So, the inner side, the skin side, is 80% of lensing modal color, and the 20% kapok. And the outside is only modal. So because the outside layer is stronger than the inside, it will drag the moisture from the inside into the outside, and where here it will evaporate. The kapok is, as mentioned before, a very short and fine fiber, so it cannot be spun on its own in 100% in a pure yarn. The spinner Martin Fildi, they volunteered to try the spinning. It's very difficult to capture the fiber and to keep it in the yarn, but we ended up in the 20% of kapok and the rest modal. We succeeded in doing as thinner yarn as an English count 30. And the outer layer is also count 30, so we have the same thickness of the yarn of the fabric, inner and outer layer. The kapok is natural color, and the modal black is black. The developing of the spinning the yarn has going on for a long time. Different spinning systems, different sizings, in order to facilitate the knitting process. But now we have a yarn that works for production. When we came to the actual fabric making, we teamed up with the brand Pyrotex. Pyrotex is a brand that is based on pure natural fabrics, so it was a perfect partner for us, and the product is tapping perfectly into their storytelling. Knitting a double layer fabric, we had to consider how we can solve that technically, because we couldn't use a PA or a PLA yarn to connect the two layers. Even if the PLA is biodegradable, it's not cellulosic. So therefore, it would pollute the cellulosic raw material. We ended up knitting the fabric in a double construction, which didn't require a binding thread, but interlaced the two layers. After a year, we had a fabric we could test, and as you can see, it has a good performance. The MMT, which is moisture management test, it goes up to 5, which is excellent. We compared it also with a 100% modal, and it reached the value 3. It's obvious that monomaterial blends have limits. But if we could substitute all the leisure fabrics with pure, for example, cellulosic fibers, a lot of textile would remain in a pure material stream. This is not for high performance use, but it's for normal sports use. So now it's finally commercially available. And what can we say about the fabric climate-wise? It's renewable, modal is from wood, and kapok from the non-food fruit, from the tree. In a chemical recycling process, the kapok fiber will disappear before the modal fiber is processed into pulp, because the cellulosic content of the kapok is very low. But as the kapok tree is growing not only for fibers, but also for other agricultural reasons, and it continues to make these fruits every year, there will not be a shortage of the fiber. And that means that there's no urgency to recover this raw material of kapok. But the initial initial resources to extract kapok fibers is very low, and the fiber needs very little preparation before using it as a textile fiber. So it's not that a lot of resources is used to make kapok fibers into yarn. But it's important to recover the lyocell fibers, because we can save the trees, the raw material, and some of the resources it takes to turn tree into pulp. Our aim is to be regenerative for a future without waste, and kapok is regenerative. For many years, I've had a sort of crusade towards against the 3 to 5% of elastin and other elastic fibers which are mixed with cotton into t-shirts and trousers. And why do I have that? Because this small percentage of synthetic fiber pollutes a lot of, for example, cotton or any other fiber that could be clean if not. When this mixed material, which is mixed only because of a little percentage of elastic fiber, should be is recycled, then it's a downcycling because it's mixed, or we're going through a resourceful recycling process that costs, it costs more resources, and so we can recover both materials because we have to split them then. This could be avoided if we had a monomaterial textile. So, if we could substitute the synthetic stretch with a biodegradable material, for example PLA, the percentage of the cellulosic material, for example cotton, would also be biodegraded together with the PLA. So, the biodegrade process takes up land and marine for years. And the raw material plus the resources it represents disappears. So it's not a solution to biodegrade. In order to substitute the blended materials, I can suggest to applicate a slightly over-twisted yarn or a crepe twist yarn, to substitute weave with knit, or using weaving structures that allows movement. This sofa is a good example. The aim was to make a fully fashioned cover for a sofa, and I started weaving the upholstery, but I could not solve all the corners. It continued to crinkle until I switched to using knit, and then it was all worked. And that was the only thing I added. It was only using knit, there's nothing else. So this is what we can do if we're aiming for comfort stretch and not for the high performance stretch. Of course, the most important thing is to use better fibers, longer, finer, better elasticity to obtain this to obtain these end uses. I'm almost at the end of a project researching on mechanical stretch. It's a combination of a special yarn twist and an open weaving or knitting and a finishing in free, so we just leave it free. The result is not only comfort stretch, but it's also a better recovery of the fabric. This is obtained by normal average fiber, so it's not the special fiber, better and longer fiber I mentioned before. And this special yarn twist, it doesn't give the dry handle that we normally have with a crepe twist. So, what I really want to say today could be summed up in these 3 bullets. Which needs must this textile meet? That's the most important question you must ask after, of course, having asked, is there any need for doing this new project I'm thinking about? I think it's important not to overdo textiles. If you think, for example, about furniture fabrics, a lot of furniture fabrics, they reach 100,000 ROPs. And this means that the fabric will still be a fabric, even when the whole structure of the sofa is not existing any longer. And to obtain a durability like that, then you will have to have added probably 10% of PA to the wool. If you instead used a little bit better wool, a little bit more twist, then you could reach a fabric 50,000 ROPs, which will do for a lot of sofas. It's very few sofas that needs to reach the 100,000 ROPs. And therefore, it's important to be very specific about what is the aim of the fabric, what request has the people who wants this fabric. So we don't overdo it. We can also think about the iPhone we all have in our pockets. How much do we use? Do we use it fully out? No, we don't. Then we have the materials. How do the materials get along? And if the materials are compatible and they can keep our material streams clean, then we are not having any waste. And that is what I think it's the most important thing, that we design regenerative for a future without waste, and we continue to use the material. Thank you for listening.
Much more importantly, you now have the opportunity, now that we've seen this mono-design philosophy, does anyone want to ask a question? You've got your opportunity. Can I persuade you to stay with us afterwards, because they might not want to ask the question publicly. So if I could have you just to the side of the stage.
Sure. Absolutely, I will be happy.
But can we once again show our appreciation for Marie-Louise?